fraction is positive, and R is all R2 is always positive, then the two things are being repelled.
Yeah, let's work on the wording a little bit here. If this is positive, then the force is in the positive R2 direction,
Okay.
R2 hat direction. If this is negative, then the force is in the negative R2 hat direction.
Okay.
Is that sufficient?
Yes.
Okay. Other questions?
Yeah. So if the force of electricity if it was like 2-1 instead of 1-2, would that R hat have a 1 next to it?
Yes, it would.
So it's always the second number?
Yes. All right, let's do a little plug and chug. I've got a charge here, let's assume a point charge with a charge of 4 microcoulombs. I have a charge here, call that Q1. Q2 is -3 microcoulombs. Something I forgot to do again. We'll do it, I guess, Wednesday, the pre-course assessment. Q2, -3 microcoulombs. Distance between them. Let's do a different number, 2.5 meters. What is the force? The electric force on 1 from 2. Well, straight plug and jug. So negative, try that again. I have K, E, times 4 microcoulombs, times -3 microcoulombs, divided by 0.5 meters squared, R2 hat.
Question. Is that mu symbol or is that a new letter?
It's a mu.
So that's a mu. And then there's just a C afterwards.
Coulomb. The SI unit for charge is the coulomb.
Which is just a big C.
Yep.
Okay. So where does the mu fit in? Where does that just go?
It's a prefix.
Okay.
If I did kilograms,
Okay.
kilo means 1,000. So this brings up, what does mu mean? What is it as a prefix?
Micro.
Okay. And what is the mathematical interpretation of micro?
Point 1,000.
0.1,000?
No, point 0.0000, so 4 decimal places to the right.
And then a 1?
No, another one, 0. Then that might be micro.
What is it? Is it like 10 to the negative? Never mind. Never mind.
You said, all right, first off, if you're moving it over one place, we got a prefix for that. 2 places, prefix for that. 3 places, we got a prefix for that. After 3, it's in multiples of 3. So you aren't going to have moving 5 places. You can move for 1, it's deci, 2 centa, 3 milli, and then jumps to 6, 9, 12, and so on. 10 to the -6th. Micro is going to show up a lot in this class, as is nano. So micro for the prefix. Micro, 10 to the -6th. Nano, pico,
-15.
okay, yes, that is the pattern.
Does it start with,
What'd you say?
does it start with an F?
It does start with an F.
Okay. Oh, I forgot the name of it.
femto.
Oh.
We will hang out in this region most of the time. Occasionally, that's when it's going to pop up. I don't recall having done femto coulombs before.
We have Pico?
Yeah,
Okay.
we'll do picofarads. Also, we'll get to there. All right. Now, we have everything here except for this KE, which I threw up over there, or wrote up over there. Anyway. This has two names, and I will flip back and forth, sometimes in the same sentence. This is either known as either the electrostatic constant or Coulomb's constant.
Is Coulomb's a name that, like, somebody's last name? Or is it just?
Yes. It's
Because
the
I
person who
just-
came up with,
Yeah.
in essence, that relationship over there, the force.
It's just a weird thing to call something, so it has to be a last name.
Son of Mr. and Mrs. Coulomb, I assume. Or Monsieur and Mademoiselle, or Madame. I don't know, could be Mademoiselle. I don't know its history. All right, since it is a constant, it does have a value, and that value is quick and dirty, the value in other words, it's roughly equal to 9 times 10 to the 9th Newton meter squared per Coulomb squared. On a calculator, 99. More detail, 8.99 times 10 to the negative 9th. Or in the lab that you'll be doing, they take it out to 10 decimal places. You guys, why not?
That's, what is the SI?
Where are you looking?
Or like 9 to
Newton meters.
Newton meter squared per Coulomb squared.
So that's for the electrostatic constant?
Yes, or Coulomb's constant, whichever way you're feeling the more today.
Did we say what a Coulomb is?
The unit of charge. Just to give you some sense, if I souped up the Van der Graaf generator, you know, the one of those things you put your hand on, the hair sticks up, that's generally in the microcoulomb range. If I had a 1 Coulomb charge here, we'd be in trouble.
As in like, yeah, kind of strong.
Possibly.
Really?
Yeah, really. It's a very strong charge. Think about Van der Graaf generator. You've seen those people with their hands on it, hair sticks up.
It's like a ball.
What's it called?
Van der Graaf generator.
Is it the clear ones, or is that something else? Like, you know, they have those clear ones that have.
Oh, the ones where you see the,
Yeah, you see.
those are,
Something else.
that's
Oh.
argon inside there, that's something else.
Right, yeah. That has micro.
That's micro on it.
Oh.
So 1,000,000 times more charge would be a cool.
Might be a little frizz after that.
All right, so let's finish this off. There's no clock in here, so, we'll just go till we're tired, which is, you know, 11 o'clock or something. If someone would be kind enough to use a calculator to actually calculate this. And more than one person would be very helpful, because not everyone knows how to use their calculator when you start throwing in exponents.
So, for an example, if you said micro is whatever generator you just said the name of,
Van der Graaf.
Van der Graaf, what would be an example of like the smaller ones? Or are those really specific for just like one,
Nanocoulombs,
or just smaller?
My charging the PVC pipe there probably is nano or pico.
And is that an N, I assume, for nano? Or an A?
That,
Then,
that's an N.
for some reason I thought it was an A without the line through it.
In essence, isn't that an N?
Yeah. You're,
It depends on your font. All right. Do we have an answer?
I may have done this completely wrong, but I do have it.
-3.
-3?
It's not what I.
That's not what I got.
I did all that.
All right, so we have an answer of -3. What else?
Negative 4.32 E11.
That's what I got.
That's what I got too.
I got.
And you got, say,
And then that's what you got.
so let's assume the majority is right here, or the plurality, since most people were silent. However, I would take off points for that answer.
R2 hat.
Okay,
Newton meters.
I would still take off.
Newton meters squared.
What did we just find?
Oh, is it
Newtons.
Oh, it's Newtons.
And whether whichever order you put those in, technically doesn't matter. All right, let's think about this answer. One, it's not a particularly strong force. But, so we got 4.32 times 10 to, oh, I wrote that wrong. I think it was said correctly. What's wrong with that answer? Or is that what someone said?
That's what,
That's really good.
that's
Should
what
it be
I got.
positive?
No, it should be negative. But when I said it's a small force, that's not a small force. That's a huge force.
Oh, is it supposed to be like?
It's 9E9, right?
Yeah, that 11, that can't be right there.
Do we have to like take
Is that
out
negative?
the
Is it
the
supposed to be
micro, like, do we have to convert
Those are 10 to
it?
the -6 there.
So we have to convert it to normal
Yes.
coulombs before,
Yes.
yeah, I didn't do that.
So I'm guessing this is E -1 or -0.432.
So instead of 4, it's supposed to be. Well, like, what are we converting?
The micro is 10 to the -6.
Be 0.000004.
Oh, that's not.
Wait, you got to the 11th before, we're now throwing in a -12. All right, so you got 9 times 10 to the 9th times +4?
Yeah.
4 times 10 to the -6 times -3 times 10 to the -6 over 0.25. 0.5 squared.
It's negative 4.32.
-4.32?
Yeah. Wait, no, it is negative 0.432.
R2 newtons or newtons R2. I guess traditionally the unit vector comes at the end. All right, so it's in the magnitude is 0.432 newtons. The direction is -R2 hat, which means that since this is 2, the force on this is in the -R2 hat direction, which means towards it, which we would have suspected anyway because they're opposite charges. I would expect them to attract. Which brings up an important piece here. When you are figuring out the direction of a force, the two options, think through it or play strict adherence to the math. So, we'll take a similar problem there. I've added a line here, that's 0, this is 0.5 meters, negative 0.5 meters. I am going to put in this spot right here a negative 3 microcoulomb force. I'm going to put here a 4 microcoulomb force, micro not milli. And over here I'm putting a 4 microcoulomb charge. I misspoke before, these are charges, not forces. However, there are forces involved here. And what I'm asking you, now we've done the hard part of the math already. What I'm asking you is, what is the total force acting on the negative 3 microcoulomb charge? I'll give you a moment. Just recognize half the problem we just did.
So, you're trying, can you repeat the question?
All right, so that's the problem we just did right there.
Yeah.
Okay. What is the total charge acting on this? And so before anyone works it out, just think for a moment. If it's the typical class, half of you will miss it.
Nice. So,
Just think through it before wording it out. I did this as a multiple choice years ago. I was saddened by the number of people who missed it.
can you do a multiple choice now?
Yeah, that was spoil it. When I typically do multiple choice, I put the correct answer first, and then I put the incorrect answers, and then I sort it by usually magnitude. All right, this is gonna be great. Tears of joy, that's what we're looking for here. In unison, 3, 2, 1.
Negative
Negative
8.6.
Mike.
And the correct answer is? Ethan?
0?
Yes.
Wait a minute.
And this is what I meant by think through the directions. The force on this from this charge is that way. The force on this from that charge is that way.
Wait.
That's 0.
Opposite track, that's a negative charge, that's a positive charge, it's attracted here. That's a positive charge, it's attracted that way.
But then there's another charge from the 4 going toward it.
Another charge from 4 going
4
forward.
piece. So
That's acting on 4. Yeah, there's those charges there.
So when,
So it's not gonna be just the opposite? So like, we did that first half,
Yeah.
and that was a positive number, that.
It was negative 0.432.
Oh, okay.
But,
It's the same because you square the distance, so the outcome would be the same, so it's the same force, right?
the same magnitude of force. Now, let's take a look at solving this 2 different ways. One, the thinking through it, I know that it is going to be pulled this way and pulled that way. Because these are the same distance from it and the same magnitude, then, or same charge, I just should say, same charge, it will be equally pulled in both directions, so the net force on this will be 0. But if I went through the math, if I plugged into the force equation, I'd end up with here, negative 0.432 newtons, and here, negative 0.432 newtons. And the most common mistake is then to add them together. The trouble is, they have 2 different references. If I call this 1, 2, and 3, this is negative 0.432 newtons R1 hat. This is negative 0.432 newtons R2 hat. R2 hat. That's what these 2 forces are. They do not have the same reference. So if you're playing strict adherence to the math, you need to get them in terms of the same reference. If I say to the right is positive, then R1 hat is positive. R2 hat is, try that one again. If I say to the right is positive, we'll just say positive I hat. That old friend. Negative R1 hat is that direction, so this would be negative 0.432 newtons I hat, plus negative R2 hat, well, that means towards R2, or towards charge 2, which is that way, so that becomes positive 0.432 newtons I hat, which is 0. There's a lot of stuff that we're gonna do where we'll think through it as opposed to playing strict adherence. Was up at the time? That was. So we'll end on that lovely note. Tomorrow I'll bring the lab in, and for those who've had me before, I'm sorry, there are no pre-labs this semester.
This whole semester.
I just do that for 151 for whatever reason. I think the original intent was I'd do it for more, and then I decided, nah, that's good.
Nice. Oh my God.
Pardon? 8 o'clock. 8 o'clock. We're down in, we're gonna meet down in the other room. Just to give you a heads up, it is a lab that I have done, but no student has done. This is gonna be the first time students have gone through it. It is gonna be longer than probably is realistic, but I don't know the timing yet, so tomorrow I will figure out what's appropriate for 2 hours.
So if we get done in 20 minutes.
Then you have now doomed all future 152 classes.